In this video, we'll learn how to create fitted line plots with the Data Analysis Toolkit and conduct regression analysis to go with it. We saw in an earlier video some data on day shift and night shift production, and we ran multiple plots to look at those side by side, and we were saying, well, it looks like day shift produces more than night shift, and we studied that with a t-test. I want to look at something slightly different now. I was struck that there seems to be a gradual increase for both of them, and I wondered if there was some kind of relationship on any given day between what day shift produces and night shift. And the way to do that is to look at a fitted line plot. It's empty at the moment, but I'm going to select day shift production for the x-axis and night shift production for the y-axis. That's a fairly arbitrary choice which way round it is. And I will see a fitted line plot, which immediately gives me an r-squared value of 28%, which isn't much, but it does seem to indicate that there's some kind of a link between what the two shifts have produced. I also have the option to select a confidence interval, which is a red dotted line that shows the range within which we believe the line actually lies. That's a pretty tight one because we've got quite a bit of data here. And you can also have a prediction interval, and that shows the range within which individual data points are expected to lie in the future. Both of those have a 95% level to them. You'll notice, by the way, that the graph has suddenly changed its axis because Excel has its own way of determining what is the appropriate scaling, and so when we put those green lines on, it updated automatically. You can manually change the axes in the toolkit if they don't suit your particular application. We've also got a prediction equation here, a bit too long to read out, but basically there's your outcome, the night shift production, a constant, and then the slope times the day shift production in the normal y equals b0 plus b1x format. Scrolling along further, we have some analysis of the residuals. Now, this is an important technique in regression because it helps you to see whether there's any problems with your model, such as special causes or perhaps curvature that you hadn't expected. The residual errors are the distances between the individual data points and the line on a vertical axis, as I'm trying to show you there. And we would expect the residuals to be random, which means that they would be normally distributed. Well, that looks fairly normal on that histogram, and the normal probability plot is a pretty straight line, so yeah, it does look like they're fine. Another thing that we can look at is the relationship between the size of the residual and the fitted value. Does it steadily get bigger as the fitted value increases? Not really. And does the size of the residual change depending on the sequence in the data? No, there's nothing strange going on there. So that looks fine. And then we've got some further analysis here that in particular gives us a p-value for regression. And that means the probability that this is just a random association, then there is nothing really to see. And that p-value of 0 tells us, yeah, we definitely have proved that there's a link between the day shift and night shift production. In the next video, I'll show you how to prepare Pareto charts for discrete data.